Alrighty, CNT120, Chapter 5. We're hitting our multiplexing terms. So real quickly, we mentioned time division multiplexing. Old T1 lines would use time slots. One time slot for this phone call, next time slot for the next phone call, next time slot for the next phone call, and it would cycle back. You know, could almost think of it as like railroad cars driving by. Each box car was a chunk of phone conversation. And then statistical was an advancement where it would, you know, if there was no phone call in slot 5, it would still get used by another phone call, just filling in and using all the slots. Then we mentioned frequency division multiplexing. This is literally how early cellular phones, even some cell phones will use a different frequency bands, if you will. But our common example is DSL, that we had digital subscriber line. And a phone line is your regular phone line was using the lower frequency band here, the voice frequency. The DSL modem took your computer signal, converted from digital to analog, and multiplexed it into a higher frequency band. So this one line was carrying both phone and data at the same time. That was your frequency division multiplexing. And then wavelength division multiplexing you run into with fiber optic, where you're literally using different wavelengths of light. We could think of it as different colors of light. I think they give you an example of light blue, red, green, dark blue. Each wavelength of light is essentially, I'm using little air quotes here, a different color. Now, the wavelengths of light that are getting used for fiber optic are near infrared. We usually can't actually see them, but you could think of them as different colors. So you could have, in this case here, 4 different data signals multiplexed together across one fiber optic cable, and that's kind of what they're showing you here. And each of those would be its own conversation, its own data signal. That can get commonly used between, buildings or parts of campus where I can take my one piece of cable and multiplex together multiple data signals. Now we move into some of our early copper cabling. When Ethernet started, we were using coax cables. So we're going to touch on coax just to kind of familiarize ourselves, at least be aware of what it is. Here is this is the diagram of coax cable. This is what it looks like when you start peeling off the layers. We have the actual copper conductor here. We have the insulation here. That's this plastic insulation right there. Then we have the foil and braided shielding out here, and then the outside jacket or outside sheath, if you will. Those are the parts of our coax. They are noted or numbered by our G radio guide. That gives us the sizing or the notation of. So you run into things like RG8, RG58, and so forth. Now, these are old school. The first Ethernets were using RG8, 10-base-5 Ethernet, thick net. And then later on, Ethernet used a thinner coax, RG58. And again, remember when Ethernet started, Bob Metcalf, this was his idea of tapping into the central coax bus, and the computers would send their signal across this central coax bus. And they were using these types of transceivers here. The transceiver here, this cable actually went to the computer itself. This was the transceiver that bolted around the coax cable. There it is right there. And would tap into it. And here it is literally tapped into. It's bolting around here, and this is the sending onto and off of the data network. And you ended up with this diagram showing all the computers tapped into the central coax bus. That was the thicknet RG8. Later on, using a thinner coax RG58, they started using the BNC T connectors here. The T connector would connect onto the back of the network card, and then the cables would connect from computer to computer. Here is your NIC with the T connector on. Here's the terminator that would be at the end of the network. The terminator was there as basically a shock absorber. When the signal hit the end of the network, it would absorb that so it would not bounce back into the network. And that was your thin net coax. The kind you would probably see today is more like your RG6, but you do run into RG59 and RG6. The RG6 is commonly what you would have if you have like cable internet at your house, that type of thing, using the F-type connector, this type of connector right here, RG6 with the F-type connector. This was the BNC connector, that twist lock for the thin net coax. And again, once upon a time, your coax was resistant to EMI, resistant to physical damage, greater distance than twisted pair. It is slightly expensive. It is not too flexible in some cases, but the big thing is most newer networking standards do not support coax for use on networks other than, you know, your high-speed internet coming into your house kind of thing. There is such a cable called twin-ax where you have actually two connectors inside, two copper cables, if you will, inside, and this can get used for short distance, high bandwidth connections between devices. This can be cheaper than fiber. Fiber in some cases is getting cheaper, but you might run into twin-ax in this kind of form right here. Looks more like this where the transceivers are actually pre-installed onto the end of the cable. Now, before we move into twisted pair, let's remember this. This is always a healthy reminder I do for people. Remember when we say Ethernet, just Ethernet, we're thinking 10 meg network. When we say fast Ethernet, we're thinking 100 meg network. When we say gigabit Ethernet, we're thinking 1000 meg or 1 gig network. And then 10 gig is just that, a 10 gig network. Okay, but these first couple terms here, remember Ethernet is 10 meg, fast Ethernet is 100 meg. That's what we mean by those terms. All right, with that then, moving into our twisted pair, let's remember a lot of what we deal with in twisted pair cabling came from phone days, using the unpaired, not twisted cable. And in early days, this was phone line number 1, and then the outside wires would be phone line number 2. That's what I got with this right here, with this phone line. And my 4-pin connector here, RJ11, was what would get used for your phone connection. Well, that evolved into what we know now as twisted pair cabling, where I have 4 pairs of cable that are twisted together for cancellation purposes. And I end up with the blue, orange, brown, and green wire pairs. If I look at its structure, I do have the outside jacket or sheath. I cut that away. I'll usually find my 4 twisted pairs, and I cut off that insulation. I would find the conducting core. If I'm dealing with maybe a category 6A, category 7 type cabling, I start running in the shielding either around the whole cable or around the wire pairs. So that would be my shielding if I were dealing with that type of cable. Fast Ethernet, I had 1 pair send data and 1 pair receive data. With gigabit Ethernet, I have 2 pairs send and 2 pairs receive. So early fast Ethernet, I was only using 2 wire pairs, the orange and the green, if you will, and the other were just there along for the ride. Gigabit, I'm using all wires now. Gigabit and above, I'm using all wires now. The wires are indeed twisted together for cancellation purposes. Now, the idea here is, remember with the crosstalk we mentioned before, with these wire pairs twisted together, their magnetic fields should be canceling each other out. And in addition, if I have an outside source of noise, when it hits this wire pair, that noise tries to induce itself into the cable. Well, if one of those wires is going one direction on a data signal and the other one's going the other way, when that noise hits that cable, those magnetic fields on those wires start canceling each other out. So it acts like, and I'm doing air quotes again, it's called self-shielding. It is not actually shielding, but it's self-shielding because it kind of cancels out those magnetic fields that are acting as noise. So the twisting of the wire pairs together was very important and still is very important for keeping a good data signal across there and minimizing the noise that might be interfering with our data signal. My outside jacket can be either, PVC, if you will, or plenum rated. We'll mention this a little bit later about plenum rated cabling, but just keep that in mind. This jacket here can be made of different types of material for fire rating. All right, here is my categories of cable, and I'm going to kind of go through these one at a time and give you examples. I put them all here for you. Starting off back in category 3 day, this was your 10 meg network. We don't find this pretty much today, but that is kind of where Ethernet for many people got started. And this was your category 3 cable here. It was barely paired and twisted, if you will. Well, as we needed to start moving more data through per time, To do that, the inside structure of the cabling changed to accommodate a higher frequency, therefore a higher bandwidth. So then along came cabling that was twisted more, much more precisely and much more accurately. So now we started getting cabling category 5, category 5E that was capable of handling a higher frequency, so therefore more bits through per time, so a higher bandwidth. So with my category 5, I'm now able to do 100 meg, and they eventually made 5 so well that it got an enhanced rating, category 5E enhanced. This was actually able to handle gigabit speeds, your 5E over here. When you look at them in general, you don't really see any difference. That's why the labels on the side become really important. Now, as they wanted to start putting more data through per time, again, the inside structure of the cabling changes. We now start getting, in many cases, divider down the middle to keep these wire pairs separate, and in some cases, even some shielding around the outside of the cabling. And sometimes you run into that as well, giving us the capability, as we see here, of getting into the gig and 10 gig range with these gig and 10 gig range. And then down here under category 7, 7A, in many cases you run into shielding around each pair and then the whole cable. Shooting around each pair and then the whole cable. Now we're in the need for doing some special connectors that in some cases were not backward compatible with existing devices and connections you had. On the horizon, category 8. Now we're into the, as you see here, the frequency signal rate keeps increasing, so the structure inside keeps changing to support that. And again, we're now getting shielding around each pair, around the whole cable, the whole 9 yards to give us our category 8. The structure to be able to support the high frequency signals for that high bandwidth rate. And then they remind us here about unshielded versus shielded. And here we have, you know, the extra foil shielding we saw on all those examples I gave you. Here was your unshielded and then your shielded twisted pair. And sometimes you'll see that referred to as screened, SCTP, screen twisted pair. You might see that referred to as well. Now with twisted pair, the advantage we start getting are it's relatively inexpensive, it's relatively flexible, it's relatively easy to install. I get 100 meters, which is pretty good. And I can indicate it can support different topologies, but as far as our Ethernet networks, the star topologies, it'll support all of that. Now, it does not have the greatest distances coax or fiber, and it is not immune to your electro interference. So for distance, I might need to connect my closets together with fiber to give me the distance, but then going from the closet to the computers and desktops, if you will, we might be able to just do all copper to those. And that's actually a pretty common network arrangement. Now, as I run cabling, my cabling needs to be rated for where it's installed. In a patch cable at a work area or user area can be just general rated cabling, CMG, Communications Multipurpose General. And that is just your basic PVC sheath or jacket around the cable. That's what I have here. This is your non-plenum cable. It's just patch cable material. If this does, catch on fire, it's going to emit some toxic fumes. So as long as it's contained in the room, it's okay. If I'm installing cabling between floors, between closet to closet, maybe closet down here to closet up here, I would need riser rated cable. The jacket insulation on that is a different composition of plastic. It will not release near the level of toxic fumes as your general, if you will. And now I have a riser rated cable, CMR, Communication Multipurpose R for riser. That last letter letting you know it's capable of going between floors. If I'm now installing above a ceiling or below a floor in a plenum space is where we're moving air around a building, I would now need plenum rated cabling. Again, the jacket insulation is a different composition of plastic. It's not like fireproof now. It's just, if it does catch on fire, I don't say it's kind of fire resistant, but it's not going to put off those toxic fumes that you had in the other one and, push those fumes out through the building, through the air system, if you will. So above a ceiling, below a floor, I'm usually needing your plenum rated cabling, Communication Multipurpose P for plenum, Communication Multipurpose P for plenum. And again, that cabling is going to be more expensive, but if I need to install above a ceiling, below a floor, I would be looking at plenum rated cabling. We'll come back and continue in the next podcast.